All right, here's lesson 4, scale factors, enlargements, and reductions. So things like architectural drawings, maps, and other scale diagrams are places where like drawing the actual thing doesn't make sense. It doesn't make sense to cart around the actual size of a building in a drawing. No, you just draw it smaller. So this uses proportions, and you need to make sure that all the proportions, all the dimensions in your drawing represent the dimensions of the actual thing. A scale statement compares the image size to the original size. So the image could be anything like a picture, a map, a photograph, anything that's a representation of an original thing. So here's one example where we have a map. Now, there's this line from here to here is 6 centimeters. And we're told that the scale statement is 1 centimeters to 3.5 kilometers. That means that the image, 1 centimeter on the image, equals 3.5 kilometers in real life. So if we compare the actual size over the map size, we're going to get x over 6 is equal to 3.5 over 1. And x is going to equal 21 kilometers. The other way to do this is to take your measurement, 6 centimeters, and multiply it by your scale factor, 3.5. And you end up with 21 kilometers as well. So therefore, the actual distance is 21 kilometers. So a scale factor... Scale factor is a number by which the measurements of one object must be multiplied by to determine the measurements of the other object. And it is the ratio of corresponding lengths of two similar images. So the image gets divided by the original to figure out the scale factor. So in this first example, we are given a scale factor of 7 over 2. And 7 divided by 2 is 3.5. So our scale factor is 3.5. The actual ant is 1 centimeter long and 0.8 centimeter tall. So we take each one of those dimensions, 1 centimeter, and multiply it by the scale factor. So the drawing of the ant is going to be 3.5 centimeters. Likewise, we take the actual and multiply it by the scale factor, and we're going to get 2.8 centimeters. So therefore, the ant drawing is 3.5 centimeters long and 0.8 centimeters tall. So enlargements or reductions. An enlargement or reduction of a 2D shape, you basically take the original shape and multiply it to get a bigger image. And how we know which one is the image and which one is the original is by the use of these little prime, these little apostrophes. So if you see a letter with a prime, that means that this is your image. Okay? And this is your original. Okay? Original, there's no apostrophes, there's no primes. So if the side length of AD, so we got to figure out AD. Well, that has no apostrophes, so that must mean that it's this AD. Determine the side length of A prime D prime. And A prime D prime is this one here. So we take our measurement, 1.5 centimeters, and multiply it by our scale factor.
If you are participating in
the scale factor is 2 over 1.
Event today, please meet in the cafeteria if you would like to get in on the group photo.
So multiplying by 2 gives us a dimension of 3.0 centimeters. Now reductions, they have a scale factor of some fraction, because a fraction is 0.25, which means that that's 25% of the original. Okay? So again, we figure out which is our original and which is the image, and these primes tell us that this is our image, and this must be our original. So if the length of DG is 10 meters long, so DG, there's no apostrophes, so this side must be 10 meters. Determine the side length of D prime DG prime, which is on the image. So we take our original measurement, 10 meters, and multiply it by our scale factor. Now 1/4 is the same as 0.25. So 10 times 0.25 is going to give us a measurement of 2.5 meters. So D prime G prime is 2.5 meters. If the scale factor is a number greater than 1, so 1, 2, 3, 4, 5, it means the thing's getting bigger. If the scale factor is a number less than 1, the shape was being made smaller. So determine the side length of B prime, C prime in each of the following diagrams. So B prime, C prime is this one, which means the corresponding side is 1.2. So start with 1.2, multiply that by your scale factor of 2.5, and you're going to get 3 meters. Okay, again, we're looking for B prime, C prime, which is that one. Well, looking at the corresponding shape of the original, we don't actually have that measurement, but because this is a square, this must also be 2.8 centimeters. So take 2.8 centimeters, multiply it by your scale factor of 1/2, and 1/2 is the same as 0.5, and you will get 1.4 centimeters. Okay. Well, sometimes we're just given an image with no dimensions, but they're on a grid. And what you can do here is just count up the number of squares. And I like to work almost exclusively with horizontal and vertical lines, because the diagonal lines are a little bit harder to figure out how many spots they've actually gone. So if we just kind of look at our horizontal and vertical lines here, this has a dimension of 6, meaning that there's 1, 2, 3, 4, 5, 6 squares that make up the base, and it has a height of 5, meaning that there's 1, 2, 3, 4, 5 squares that make up the height. Now our scale factor, we're told, is 2, so you take each of those dimensions and multiply it by 2. And that tells us the dimensions of our new image. So our new image is going to be 10 tall, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and it's going to be 12 wide. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now you'll notice that if we just connect the diagonal, we get the new shape. Okay. So scale factor of 3, let's go around and just count up the dimensions of each thing. So this is 2, 1 and 1. This is 3, 1 and 1, 2, 1 and 1, and 3, 1 and 1. So really we just have to do 3 calculations. 2 multiplied by the scale factor of 3 is 6. 3 multiplied by the scale factor of 3 is 9. And 1 multiplied by the scale factor of 3 is 3. Now when you're drawing your new image, you have to kind of be strategic about where you place it. If I start in this corner and I do the top part of 6, that means our shape is going to jut out into empty space, and that's no good. So let's start a little bit farther along the top. So let's start here and draw our top line. So 1, 2, 3, 4, 5, 6. Okay. The original was 2. We multiplied that by 3 to get 6, and then we drew 6. Now, in the original, we have a jut out of 1 and 1, which means in our new, it's going to be 3 by 3. And then in our original, we have a dimension of 3. So multiplied by 3, that gives us 9. And then the same thing, jut out of 3 and 3, across 6, and then you can just finish off your shape. So our new shape has dimensions 6, 3, 3, 9, and so on all the way around. Okay, so our scale statement is 1 to 3, which if we convert to a fraction is 1 over 3. So that means that each one of our dimensions we need to multiply by 1/3. So let's count up what our dimensions are. Well, the vertical part is 9. The horizontal part is 9. And this from here to here is 6. Now we run into a bit of a problem. We've got these diagonals. And how do we figure out how far that goes? Well, let me draw your attention to a horizontal line, the midline of it. So count up that midline, and it's going to be 12. So we're actually going to perform 3 calculations. 9 times 1/3, that gives us 3. 6 times 1/3 is 2. And 12 times 1/3 is 4. So let's start with the vertical portion here of 6. So we had 6, we multiplied by 1/3, so the new one is going to be 2. And then on the original, the horizontals are 9. So multiplying by 1/3, we get 3. So go across 3. Now do your midline. Now the midline, the original is 12, and on the new one it's going to be 4. So we just count 4. 1, 2, 3, 4. So there's the end point, and draw your diagonals. And you would not include that there. Okay? All right, a scale factor of 50%. Well, 50% is 0.5. So you need to figure out all the different side lengths and then multiply by 0.5. So the bottom's 10, 2, 5, 4, 6, 1, 1. And then these diagonals we don't really know, but if we count this, we know that that distance is 5, and then this distance is 2. So we can use that information to help us out. Okay, so let's start with the bottom length. So 10 multiplied by 0.5 is 5. So our bottom part is going to go 5. So 1, 2, 3, 4, 5. Now I'm starting not right in the corner because of the jut out. Okay, if I started right in the corner and I went up, I'd have to go into empty space, which I don't want to do. Okay, so we got the bottom one is 5. Now let's do this little vertical section. So 2 times, make that a little neater, 2 times a half is 1. So we're going to go up 1. And then we're going to get 5 multiplied by a half is 2.5. So then we're going to go back 2.5. So 1, 2, and then halfway. Okay, let's do this vertical section here. So 4 multiplied by a half is 2. So we're going to go up 2 from that point. Okay. And then I'm actually going to skip over and do this other side here of 6. So 6 multiplied by a half is 3. So you're going to go up 1, 2, 3. Okay, and then we've got these little sections of 1 and 1. So 1 times a half is a half. So you're going to go jut out a half. Now, here comes the tricky part. Where do we place this sort of top point? Okay, well, I know that it's the entire distance here is 5, so half of 5 is 2.5. So if we start here and count half of 2.5, that's right. Yeah, that's 5 there. 1, 2, 3, 4, 5. Okay, it's going to be right there. And this vertical height of 2 multiplied by a half gives us a height of 1. So then we can connect our 2 points and get our final image. So use the following steps to determine the scale factor. Pick one side of the image, pick the corresponding side of the original, and that is your scale factor. And then you can take your scale statement is the image compared to the original. So first of all, figure out which is your image that uses the apostrophes. This is your OG. This is an equilateral triangle, so it doesn't matter which one we pick, but we're going to take 6 over 1.5.
Madison McKenzie, please call the office.
which reduces to 4/1, which means our scale statement is 4:1. And our last page here, scale factor is the image over the original. So pick a side.
Jordan Rumpel, please go to the bookstore.
2/6, which is 1/3, which reduces to 1/3. You could also do 3/9, which also reduces to 1/3. Okay, an image length is 8.2, and the original is 2. So 8.2/2 gives me 4.1/1, which our scale statement is 4.1 to 1.